Hello, let's take a look at an example of the steel column calculator in ClearCalcs. So for this one, we will be using the steel column ASD calculator. We also have an LRFD calculator, but let's take a look at the generic column. So we'll be taking a look at this validation example. We have 6 examples for the steel column template on our website, support.clearcalcs.com. If we were to scroll down, we'll be looking at example 2. This one's a WT-shaped column with slender elements, and the reference for this can be found at AISC Companion to the Steel Construction Manual, and it would be example 8.E.8. So for our input parameters, we have axial loads of a dead load of 6 kips and a live load of 18 kips, a total column length of 20 feet, yield strength of 50 KSI, and a section size with the designation WT 7x15. So let's go back to ClearCalcs and input all of these. So our member type was WT 7x15, is this one right here. And our yield strength is automatically updated to the typical value for this section, which was 50 KSI. Our column height was 20 feet. There was no indication of continuous bracing, so defaulting this to no is good. And our position of supports is pinned at the base and roller support at the top. So scrolling down to our axial loads, we can indicate these here. We had a dead load of 6 kips and a live load of 18. So now, if we scroll back up to the top, we can see that we have an allowable compressive strength of 24,400 pounds. Going back to our validation example, the outputs at the bottom here, the available compressive strength in the example was 24.4 kip, which is the same as what we get in ClearCalcs. So let's take a look at these other values. For the applied load, we're expecting to see 24 kip. And based on this diagram here, you can see the top axial load is 24,000 pounds. So that's the equivalent. Now for these values here, the elastic flexural buckling stresses, in ClearCalcs, we're going to want to take a look at this in detailed view. So if you click down on details, you can switch from standard to detailed view. And you'll get a lot more of the intermediate calculations in the below dropdowns. So we'll take a look at capacity and pure axial loading for these values. For the elastic flexural buckling stress in the x-axis, we have 21.3 KSI, and elastic flexural buckling stress in the y-axis is 11 KSI, which, going back here, 21.3 and 11. And then we are expecting a elastic flexural torsional buckling stress of 10.5 KSI, which can be found right here. Lastly, we're going to want to find critical buckling stress of 9.21 KSI and an effective area of 4.42 inches squared. So our critical buckling stress is 9,200 or 9.2 KSI. And for our effective area, we'll look in this drop-down here. And we can see that this widget has an effective area for slender cross sections, which is 4.42 squared inches. So you can see that ClearCalcs in the example have the same outputs. For all of our examples on this page specifically, we have 6 examples. You can expect that the values would differ between plus or minus 1%, primarily due to round-off errors. But for this example, all of our values matched.